Hey everyone, today we're going to do 4-1 identifying functions notes. These are the first official notes of our new chapter. So once you're done, after you take the screenshot or the picture and submit them for a participation grade, please fold these in half and put them in your notebook. Alrighty. For question number 1, it says, suppose you inserted your money and pressed A1. What item would you receive? So over here to the right, we have a vending machine. If I look at first row for letter A and go to the right 1, it looks like I have picked the movie Gone with the Breeze. So I'm going to write for number 1, Gone with the Breeze. Number 2, suppose you inserted your money and pressed C2. What item would you receive? I'm going to wait about 10 seconds. I'm going to let you find an answer. Please write your answer and see if you are correct. For C2, I'm going to look at the bottom row for the letter C, go to the right 2 movies. I see that I should pick Raiders of the Lost Ark. So for number 2, if you had Raiders of the Lost Ark, awesome job. If you did not, go ahead and correct your answer or fill it in. For number 3, suppose you inserted your money and pressed B3. What item would you receive? I'm going to wait 10 seconds. Please go ahead and write down your guess or your answer. For B3, I would look at the second row, go to the right 3 movies. It looks like it would be The Wizard of Oz. Number 4, if the machine were filled properly, what would happen if you pressed any of those same buttons again? Normally, if it's a vending machine, typically it's going to be filled with the same item multiple times. So if I push the same button, I should get the same exact movie again. So down below it says, each time you press a button and input, you may receive a DVD and output. It does say may receive because it does look like I have one movie at B1 sold out. If it were filled properly, though, there would be a movie in stock in that particular section. So number 5, in the DVD vending machine situation, does every input have an output? Explain your response. So it's asking, if every single button that I push, would there be an available output or would there be an available response? Yes. So even though B1 is sold out, if it were filled properly, it would give me an output. So yes. So I'm going to go ahead and take a second. I don't know how good the microphone is, but I am in my apartment filming this video. If you hear a bunch of scratches, my rabbits are in their cages And if you also hear a cat crying, it's because I have the door closed and she is trying to get in. So please don't be alarmed. It is my animals. You're not just hearing a random cat cry. Or if you can't hear it at all, then apparently my microphone is not as good as what I think it is. Alrighty, for number 6, each combination of input and output can be expressed as a table. Complete the table to the right to illustrate how the inputs and outputs of the vending machine are related. So in my table, I have all of the A buttons filled in. I'm going to look back up to the DVDs available for those particular buttons. I'm actually going to wait and give you about 15 seconds to fill in the 3 different DVDs for the A buttons. So here is the vending machine. Please go ahead and write what 3 DVDs you would get for pushing the 3 A buttons. Alrighty, let's see if you are correct. So for A1, it looks like I would be selecting Gone with the Breeze. For A2, it looks like I would be selecting the movie The Godmother. And for A3, it looks like I would be selecting the movies Star Battles. So I'm going to go down on my table and fill in those 3 DVD options. Alrighty, let's go ahead and talk about the B buttons. It looks like we have B1 filled in. If I look back up to my table, if I look up back to the vending machine to fill in for my table, it looks like B1 is where that DVD is currently sold out. So for the B1 option, I would write sold out. And then from here, I'm going to wait about 30 seconds for you to fill in the rest of the table. So it looks like it filled in the next 3 DVDs. You would need to fill in the buttons that you would have to push to get these DVDs. Then it gives you a C2 button. Please fill in the DVD for what you would receive if you pushed C2. And then for the last one, it gives you the DVD. Please go ahead and fill in the button. So I'm going to wait about 30 seconds. Please go ahead and fill in your table and we will see if you are correct in 30 seconds. About 10 more seconds. Alrighty, let's go ahead and see if your answers are correct. For the Wizard of Oz, it looks like it's available in 2 different buttons. I could push B2 or B3. And then if I want to do Finding Dreamo, it looks like I would need to do button C1. So I'm going to go ahead and fill in the rest of those buttons. So B2 would be the Wizard of Oz. B3 would also, not BC, B3 would also give me the Wizard of Oz. And then C1 would give me Finding Dreamo. For C2, it looks like we would push C2 to receive Raiders of the Lost Ark. And it would look like I would also push C3 to have Raiders of the Lost Ark. I'm just going to put NB for mossed bark since I do not have enough room. And then lastly, I'm going to fill in C3. It says to the left, because each input in the table is paired with exactly one output, the relationship between the button and DVD is a function. So remember, even though B1 is sold out, if you push that, it would still give you a result of not receiving a DVD. Okay. Up at the top, it says a function is a relationship in which each input is paired with exactly one output. So it looks like it cannot be the same input, cannot be two different outputs. And we're going to talk more about that in different or future examples. So right to the right, here is a list of 4 friends and the number of pets each friends own. So on our table, we have the name of the friends. We have Mary, Carrie, Larry, and Barry. Then for the number of pets, we have 3, 1, 0, and 0. Question 7 says, can 2 or more different friends have the same number of pets? Well, yes, because the friends are the inputs. So yes, because the friends are different inputs, that means they can have the same output. It cannot be the same input have 2 different outputs. So yes, different inputs can have same output. We see here that in the table, Larry has 0 pets and also Barry has 0 pets. Because they are 2 different people, they are able to have the same amount of pets. For number 8, Mary has 3 pets. Could Mary have exactly 3 pets and at the same time have 7 pets? Well, no. Because Mary is the same person or the same input, you cannot have more than one output. So no. The same input can't have different outputs. So question number 9 says, can any one friend have 2 different number of pets? No. We just answered that question in number 8, but we're being more general. So no, because of the same reason, the same input can't have different outputs. So I'm just going to put no, and I'm going to draw a little arrow pointing up to our same explanation. Question 10. Do the inputs and outputs in this table represent a function? Explain. So I'm going to give you about 15 seconds to form an opinion. Please write your answer and see if you have the correct answer. Alrighty, let's go ahead and see if you have the correct answer. So does this input, does this table represent a function? Yes, it does. Yes, because each input has its own output. Alrighty. For each situation below, fill in the missing information in the tables. Okay, number 11, a parking meter takes only dimes and each dime is worth 6 minutes on the meter. So on the table to the right, I'm going to start at the top one. So if I have 2 dimes, I would need to figure out how many minutes that I can park. I would do the same thing if I have 3 dimes and 7 dimes. I'm going to wait about 30 seconds. I would like you to figure out how many minutes of parking that you could do with each different amount of dimes. You can use a calculator if you would like to, but you have 30 seconds. About 10 seconds left. Alrighty, let's go ahead and see if you are correct. To find the amount of minutes, I would take each different number of dimes and multiply it by 6 because 6 minutes represents 1 dime. So 2 dimes times 6 minutes equals 12 minutes. My apologies for that ugly sneeze. For 3 dimes, I would do 3 times 6 minutes. I keep spelling minutes wrong. I don't know why. And then lastly, I would do 7 dimes times 6 minutes equals a total of 42 minutes. Okay, let's go ahead and go to the second table. This time it gives you the amount of parking that you would receive, but you need to figure out how many dimes it would take to have that much parking. So I'm going to wait about 30 seconds. I would like you to try to fill in your answers on your own. You again can use a calculator if you would like to. So I'm going to give you 30 seconds starting now. About 10 more seconds. Okay, let's see if you are correct. If I have 0 minutes of parking, that means I haven't paid the meter, so that means I would have 0 dimes. For 12 minutes of parking, I would do 12 minutes divided by the 6 minutes that I get for each dime, and this would give me 2 dimes. Last one, I would do 54 minutes divided by a total of 6 minutes that I get for each dime, and this does give me a total of 9 dimes. Okay, let's go to number 12. It says each point on the graph to the left shows how many shots a player on a basketball team took and made in the first half of a game. What, if any, difficulties did you encounter filling out the tables on problems 11 and 12? Explain. So let's go ahead and fill in the amount of shots made. So if I want to look at this graph, I look at the shots attempted, that is across the bottom of my graph. If I go to 2 shots attempted, it looks like I have a dot at 0. Okay, if I look at 4 shots attempted, and then I go to 4 across the bottom, and then I look up, I do see that I have 2 different points. So I'm going to put 1 and I'm going to put the number 3 because again, there are 2 dots. And then I'm going to look at 7 shots attempted. I don't see any points, so I can't even make adjustments. So I just have to leave that blank, unfortunately. So again, I'm going to go back to the question to the right. What, if any, difficulties did you encounter filling out the tables on problems 11 and 12? Well, 11, I had all the information that I needed. So I'm going to put 11 equals no problems. But for number 12, though, for number 4, there were 2 dots, so I had too much information. Again, you cannot have more than 1 output for your input. The input is the amount of shots attempted, and the outputs are how many that were made. Because 4 was my input and it cannot have 2 different outputs, then it made it difficult to realize what to put into my table. Then for 7, it wasn't even marked on my graph because there were no, my apologies, I am blanking. For 7 shots attempted, there were no points to indicate that any were made. So the problem was too many outputs for 4 shots attempted and no info for 7 shots attempted. Alrighty. So number 13 and number 14, I'm going to wait about 30 seconds and I'm going to let you figure out which one is not a function. So number 13, it says which table is not a function. This is a multiple choice. Only one is not a function. Please go ahead and take about 30 seconds to select which one is not a function, and please write off somewhere to the side where you can fit it on your notes about why you think this would not be a function. About 10 more seconds. All right, let's see if you are correct. For number 13, the table that is not a function would be the letter B. The reason why B is not a function is because I'm going to use my highlighter tool. I look here and I see the color blue is equal to sky. I also see down below that blue is somehow equal to the ocean. Because blue is the same input and it equals 2 different outputs, that is why it is not a function. If I look at all of the other tables, it has 4 different outputs. It has 4 different inputs, and each one has its own output. None of the inputs repeat. So off to the side, I'm going to put blue can't have 2 different outputs. I'm also going to make this little note because I feel like we've kind of gotten to the point where I'm able to say this, is that if an input repeats, That's typically a red sign. Actually, I'm not going to put that, but I just wanted to say that. Okay. So I'm going to go to 14. I'm going to give you about 30 seconds to find which graph is not a function, and then please write off to the side or somewhere on your notes why you think it is not a function. About 10 seconds left. Alrighty, let's see if you are correct. The graph that is not a function is letter B again. This is because the x-axis, the one that runs left and right, this is the x and this is the y. The x cannot have two different y values. So if I were to look at this area right here on the graph, it intersects with the y here and here. It would be equal to two different y values at the same time, and it cannot be that way. So for my reason, I'm going to put x cannot or can't. I don't want to write be equal because it is not equal. X can't have two different y values. So I'm going to put x equals input, y equals output. Alrighty. For this graph, it says Jada fills her aquarium with water. The graph shows the height of the water in centimeters and the aquarium as a function of time in minutes. For number 15, label the input and output on the graph. So up above, I said the x-axis represents the input. So the x-axis is always the one that runs across the bottom of your graph. So time would be the input for this particular graph. And the height, or the centimeters, would be the output for this particular graph. For number 16, what is the output when the input is 4 minutes? So I'm going to highlight. So I go to 4 minutes. I'm going to highlight up to where I think it crosses the actual function on the graph or the line on the graph. So if I go up from 4 minutes and I go to the left, it looks like I should be at 20 centimeters. For number 17, what is the input when the output is 30 centimeters? So on here, I'm going to go to 30 centimeters and I'm going to go to the right until I'm at the line on my graph. And then I look down. It should tell me 5 minutes. So I'm going to put 5 minutes for 17. And for number 18, does the graph represent a function? Explain. Yes, this particular graph does represent a function because each minute, I'm going to put input in parentheses, has an output. And I'm going to put height centimeters. Okay, last two questions. Number 19, Estimate appropriate ordered pairs for the graph to the right. So it looks like only 10 on my y-axis and x-axis are labeled, so I'm roughly going to have to estimate. I know that 0 is always in the bottom left-hand corner, so I'm going to go ahead and put a 0 there. So because my graph starts at 10, my first ordered pair could be 0, 10. Another ordered pair is if I look at the very end of my x-axis, I can tell you 10. And if I look all the way up, it does end at 10 again. So 10, 10. Okay, another one, it looks like I have a straight line going across from 10. So it looks like no matter how far I go, it roughly looks about halfway through the graph until I make some sort of change. So I can put 1, 10, and 2, 10. But something happens at number 5 where it's just a straight line down. So I could have 5, 10, but it looks like it comes all the way down to about halfway down the y-axis. It looks like I could also have a point at 5, 5. So again, I'm going to go ahead and put dots on where I see. So here's 1, here's 10, 10. So 1, 10, 2, 10. Here is 5, 10. Here is 5, 5. So number 20, could this graph represent a function? Well, because the 5 on the x-axis is equal to 5, 5, and it's also equal to 5, 10, because it has two different outputs, this graph could not be a function. No, because the 5 on the x-axis has multiple outputs on the y-axis. You have now finished this. Please make sure that you're taking a picture and submitting this for completion, for participation, and then please fold it in half and put it in your notes.